Hello everyone, welcome to this 8th video on number theory. This video will talk about extended Euclids algorithm. We already saw that Euclids algorithm is the method which we use to find the GCD of any given two integers a and b. Now we will see what is this extended Euclids algorithm. If we have any positive integers a and b, then there are always ways to find integers m and n so that we can express the GCD as the format ma plus nb. That is, GCD of the element a and b can be written as some other integer times of a plus some other integer times of b. So there are ways to find integers m and n so that I can express the GCD of AB as the product of these plus the sum of the quantity. In other way, we can say that GCD can be expressed as a linear combination. What is the right word of writing it of this format? So m times of A plus n times of B is referred by the name linear combination of the given integers A and B. So we can express this value of A and B as a product of some integer m, as a product of some other integer n, and the addition of both of it. But we need to keep in mind that this expression of the format ma plus nb is not unique. Not unique meaning there are going to be other ways also in which you can express the same GCD. That is, you can also find two other integers called as s and t, so that s times of a plus t times of b will also be equal to the GCD of a comma b. So this is not the only answer. It is going to be one of the ways in which we can do it. So there may also be other ways in which you can express the same GCD as a linear combination. So this is how the process works. Now we will quickly move on to see how we can apply this extended Euclids algorithm, that is expressing the GCD as a linear combination of the quantities using a problem. Okay, so we will see. Find the integers m and n. So our target is to find m and n such that 512 times of m plus 320 times of n is going to be equal to 64. We already saw how to express this 512 plus 320 in terms of the GCD, which is going to be equal to 64. That is, we did the Euclids algorithm, and from the Euclids algorithm we backtraced it to find the division algorithm. Okay, so you can quickly recollect the videos, go back and watch those videos so that I will be able to express this 512 as 320 times of, so this is nothing but my A equal to BQ plus my R. B is the smaller value, A is the bigger value. When divided by it gives the quotient 1 and the remainder R. Okay, so first express this using your Euclid's algorithm and then converting it by the division algorithm. So the backtracing of it will help us to reach the initial quantities 512 and 320 from the quantity called as 64. So we are going to use the technique of backtracing. Backtracing meaning moving back. So where we are going to start? We are going to say that this 64, which is the GCD of 512 and 320, can be expressed as the linear combination m times of 512 plus n times of 320. Then what is my m and what is my n? So to find this, I begin with the number 64. What you will have to do with 64, just rewrite the value of 64 in terms of the quantity to the left hand side. How you can express this 64 as? 64 can be expressed as 192 minus 128. 192 minus 128. So this is going to be our step 1. Now this remainder has been expressed. Now move on one more step. So what is going to be the next step? I need to replace the next remainder 128. Where is the next remainder 128? Here. What I need to replace this with? By the quantity to the left. How I can express this 128 as? I can express this as 320 minus 192. If this goes to the opposite side, it becomes minus. So I write this 128 as 320 minus 192 times of 1. Don't forget, you will have to multiply with this 1 over here, because if we are going to have some other number and miss this, then that will cause a problem to us. So keep tracing the factors over here. So this is 192. This 192 can be written as 192 times of 1 minus 320 multiplied by 1 is 320 times of 1, minus into minus plus 192 times of 1 into 1 makes it as 1. So now what happens over here? So this is not 129, it is 192. Okay, so 192 times of 1. Now I can club this 192 over here and here, which will give me 192 times of 1 plus 1 minus 320 times of 1, which is 192 times of 2 minus 320 times of 1. So we are done with our step 2. Now moving back one more step. So step 3, what is the last remainder to be replaced? 192. How is this 192 replaced as? By the quantity towards its left. What are the quantity towards its left? 512. Bring this to the opposite side, minus 320. And where is the value to be replaced? Here, this 192 to be replaced. So I can replace this 192 as 512 minus 320 times of 1, and now this 192 alone has been replaced. There is going to be multiplied by 2 towards this side. So don't forget this is the common mistake we will do in exam. So please be cautious to trace this 2 back to the position. Minus 320 times of 1. So this is going to be 512 multiplied by 2 will be 512 times of 2 minus 320 times of 1 into 2 is going to be 2 minus 320 times of 1. So now let me combine this 320. Hence we have 512 times of 2 minus 320 times of 2 plus 1. So you have 512 times of 2 minus 320 times of 3. This is nothing but the expression for 64. Now compare it with the given expression. They want 64 to be expressed as 512 times of n plus 320 times of n. Now on comparing, I can see that my value for m is going to be equal to 2. And on comparing, you notice that n takes the position 3, but the symbol over here is plus and the symbol over here is minus. So be cautious over here. Again, if it is going to be plus, then you can take this value directly as n. If you have a minus sign, then adjust this minus sign with your n and make this as n equal to minus 3. So that you will not have any issues in identifying the given expression in the linear combination format. So your m is equal to 2 and your n is going to be equal to minus 3. Now let us do one problem like from scrap from the beginning to the end, so that we will get comfortable like what is the entire process, because this is going to be a repeated university question for us. We need to get comfortable with the entire of the process. So we will do one more problem to get accustomed to the practices. Fine. Question number 2, use the Euclids algorithm to find the GCD of 1819 and 3587 and express the GCD as a linear combination of 1819 and 3587. So first is to find the GCD of the value. So to find the GCD, what we do is we begin with our Q, A, B, R format. Let be the A be the biggest of the number 3, 5, 8, 7 and the smallest number be 1, 8, 1, 9. When I divide, how many times this 3, 5, 8, 7 can be divided by this 1, 8, 1, 9? You can divide it one time, 1, 8, 1, 9. So the quotient will be equal to 1 and it leaves a remainder of 1, 7, 6, 8. So remainder is 1, 7, 6, 8. The algorithm doesn't stop. You shift the numbers 1, 7, 1, 8, 1, 9 to the position of A, 1, 7, 6, 8 to the position of B. Again do the same process. 1, 8, 1, 9 is going to be divided by 1, 7, 6, 8. It goes one time 1, 7, 6, 8 and then it leaves a remainder of, say it is going to be 51. So it goes one time and this is going to be 51. The next stage is going to be, no, this 51 is not going to be 0, so I shift again the positions. 1768 becomes my A and 51 becomes my B. Now what I'll have to do is 1768 has to be divided by 51. If I divide 1768 by 51, it goes 34 times. 34 times to give me 1734. So again it leaves us with a remainder of 34. So it goes 34 times here and the remainder is going to be 34. Again remainder is non-zero, so shift your positions of A and B. So 51 enters with A, 34 enters with B, and now you repeat the process for 51 and 34. 51 is now divided by 34. How many times it goes? It goes one time, 34, and leaves a remainder of 17. So 17 is the quantity, it goes one time. Now again this is non-zero, so what you will have to do is you will have to repeat the algorithm. Shift the positions, 34 comes here and your R, which is 17, enters B. Now I know that 34 when divided by 17 goes how many times? Yes, 2 times exactly, to give the value 34, leaving you a remainder of 0. So the remainder becomes 0 when we multiply 17 by 2. So the algorithm stops over here as we have reached the 0 point. So what is going to be the GCD? GCD is going to be the value taken by the position B, or the last non-zero remainder. So I now know that the GCD of the quantity 1819, 3587 is going to be equal to 17. Now from this 17, I will have to rewrite this, express GCD. What is this GCD? 17. This 17 has to be expressed as a linear combination of 1819 and 3587. That is, I need to express 17 as 1819 times of M plus 3587 times of N. So this is my second requirement. So for the second requirement, what we will have to do is, I will erase this part so that we will be able to rewrite it of the correct format in the using the division algorithm, so that we will be able to retrace this quantity as. So what is the format required? A equal to BQ plus R. A, so 3587 will be equal to 1819 times of 1 plus R, 1768. Second line, A 1819 will be replaced with 1768 times of 1 plus the remainder 51. Third line, A 1768 will be replaced as B times Q. So 51 times of Q. What is my Q? 34 plus the remainder 34. Now the next number to be replaced, A 51 can be replaced as B times Q. So 34 times of 1 plus the remainder, which is going to be 17. The last stage, A 34 can be replaced as 17 times of 2 plus the remainder, which is going to be 0. Now this is going to be the quantity which we require to backtrace our GCD. Where is our GCD? The GCD is over here, 17. So step 1, replace 34. First step 1, replace 17. Step 2, replace 34. Step 3, replace your 51, and step 4, replace your 1768, and then we will be arriving at our beginning point 3587 and 1819. So from 17 I will be able to get this 1819 and 3587 using my backtracing. So what we are going to do is backtrace the answers now. Okay, let us start our retracing back. What is the first number to be retraced? 17. So we will have to begin with 17. How I can write 17 as? 17 can be rewritten from the back step. Okay, go this way, rewrite it as 51 minus 34 times of 1. Okay, step 1 is over. Now go to your step 2. What is the next number to be replaced? 34 is to be replaced. Where is 34? Here is our 34. How to replace this 34? By the back traced value. What is going to be 34 to be replaced with? 1, 7, 6, 8 minus 51 times of 34 is the quantity what I replace this 34 with. But this 34 has to be multiplied by 1. So the expression towards the left has to be multiplied by 1. Don't forget this. So this is 51, which I can write 51 times of 1. On expansion, this becomes 51 times of 1 minus 1, 7, 6, 8 times of 1. Minus of minus becomes plus. 51 times of 34 times of 1 is 34. Now here we have a 51, here we have a 51. Let us club both of them. So it is 1 plus 34 times 1768 times of 1. So it is 51 times of 35 minus 1768 times of 1. So second step is also over. Now move back to the third step, which is the next number to be replaced. The next number to be replaced is 51. Where is our 51? Here is our 51. How to replace this 51? Back tracing it. We have this 51 to be expressed as 1819 minus 1768 times of 1. Now this 51 alone is replaced by this left quantity. But what is the factor which is left out to the side? 35. This is the quantity which we must not forget to multiply it with. Okay, 1768 times of 1. So this expression now becomes 1819 times of 1 into 35. So 35 minus 1768 times of 1 into 35 is 35 minus 1768 times of 1. So now what we have totally is going to be, we can club this 1768 and 1768. Hence we have this as 1819 times of 35 minus 1768 times of 35. I am taking plus 1 over here. So it is 1819 times of 35 minus 1768 times of 36. Now next step and the last step. The last remainder to be replaced is 1768. Where is it? Here, 1768. What we'll have to do it? We will have to retrace it back and then replace it with the quantity to the left. So what will this 1768 be replaced with? 3587 minus 1819 times of 1. And this 1768 has been replaced. Don't forget to multiply with this 36 to the side. And so copy paste the first part as such, 1819 times of 35 with the minus sign. On expansion, we have 1819 times of 35 minus 3587 times of 1 into 36. So that is 36. Minus into minus, this makes it as plus. So we have this to be equal to 1819 times of 36. Now next stage, 1819 and 1819 over here, club both of them. So it is 35 plus 36 minus 3587 times of 36. So 1819 35 plus 36 makes it as 71 minus 3587 times of 36. We are almost there. We have now reached the starting point. What we wanted was, I need 17 to be expressed as 1819 times of n. 1819 times of n. So what is going to be in the position m? I have the m value to be, m is going to be 1819 times of m. So my m value will be equal to 71. And what is the next part? I want 3587 times of n. I have 3587 and I have an n, but the sign over here is plus. So if I put a plus over here, this minus sign will be adjusted over here, and so on comparison, plus 3587 times of n, and now this n can be got from the above equation as minus 36. So what are the values of m and n that satisfies the given linear combination? M is equal to 71 and n is equal to minus 36 satisfies the relation that the GCD can be expressed as a linear combination of the given two integers a and b. I hope this is from the scrap till the end, and this will be our 15 marker. and frequently asked question in the university examination. So make sure you are able to work from the scrap till the end. If you find something difficult or you need help on it, please ping me in the comment box. We will try to get back to you as the earliest. Okay, make sure that you are comfortable with this process of extended Euclid's algorithm. Happy learning, keep learning.